Imagine being able to search for songs, movies, or images not by exact words, but by similarity, like asking Google to find pictures that feel like your photo. That's the magic of similarity search powered by vector databases. Today, we'll explore this step by step, beginner-friendly style. Similarity search is how machines find things that are alike. Unlike keyword search, which matches exact words, similarity search finds items close in meaning. For example, searching happy should also find joyful. This is possible because we represent data as numbers, vectors. Machines don't understand words directly. They only understand numbers. So, we turn words, images, and sounds into vectors, lists of numbers that capture their meaning. Think of it like mapping every idea to a point in a huge galaxy of concepts. The process of converting data into vectors is called embeddings. Embeddings capture the meaning of things. For example, in a 3D space, king minus man plus woman equals queen. This shows that embeddings keep relationships and context intact. But here's the challenge. When we have millions of vectors, how do we search through them quickly? That's where vector databases come in. They store vectors efficiently and use clever math to find the closest matches in milliseconds. To know how similar two vectors are, we measure distance. The most common ones are Euclidean distance, cosine similarity, and dot product. Imagine placing dots on paper. Closer dots are more similar, farther dots are less similar. You already use similarity search daily. Recommendation systems on Netflix, personalized shopping on Amazon, image search on Google, and even face recognition on phones, all powered by vector similarity under the hood. Similarity search isn't just for words. Images are turned into vectors too. Upload a photo of your dog, and search engines can find similar-looking dogs. Even voices and music are stored as embeddings for similarity-based retrieval. Of course, there are challenges. Vector search can be expensive for very large data sets. Results may not always be perfect, since similar is subjective. Also, keeping embeddings up to date as data changes is tricky. The future is exciting! With advances in hardware and AI, similarity search will power multimodal AI, systems that understand text, images, audio, and video together. Imagine searching with a sketch and finding a real product instantly. So, to wrap up, similarity search allows machines to find close meaning matches. Embeddings turn ideas into vectors, and vector databases make it all possible at scale. You're already using this tech daily without realizing it. If you enjoyed this journey into AI, hit like, subscribe, and share. It really helps the channel grow.